Okay, our objective is to use the counting principle to find probabilities. We are also going to continue talking about factorials today. Just a reminder again that your probability quiz, which is like your probability test, will be Monday. You do not have a big chapter test in Chapter 6. We just had 2 smaller tests. And then after that next week, we're going to move on to the cumulative review. So you know a cumulative exam is coming up, which will be on Chapters 1 through 6. Okay? Okay, we're going to start with going over the warm-up, then we'll move on to homework. Okay, warm-up for number 1 says, how many ways can letters A, B, and C be arranged? Amberly. Good, how did you get that? Awesome. And Amberly, we can also call that what? 3 times 2 times 1 is the definition for or. What's this called? Good. And either way for this one. You could also say 3 factorial. If you did not change that to 6 on this one, that's fine. Okay, 2A, what is the probability of rolling a 3 or a 4 on a 6-sided number cube? Abigail. Good. 2/6 or 1/3. Part B, Josh, what are the odds in favor of rolling a 3 or a 4? Good. 2/4 or 1/2. Part C, Skylar, what are the odds against rolling an even number? Good job. 3/3, which is the same thing as 1/1. Camille, if you roll a number cube 30 times, how many times would you expect it to roll on a multiple of 3? Good job. The answer here is 10 times. If you were confused on that one proportion that you could have used is 2/6 equals x/30. Use cross product solve. You end up with x equals 10. That's just one way. There were a couple ways you could have solved that. Kevin. Yes, if you have 10/30, I mean, basically that's correct. All you're doing is plugging your 10 back into the proportion. Neil. Okay. Drew? I know. You know, I typed these note packets in one summer, all of them, chapters 1 through 10. So some of them, yes, some of them I would think I went too quickly through. I was just worried about getting the problems down, and I have typos. So that's okay. You can fix them as we're going. I just didn't, I like note packets better than having you guys and girls use a notebook. Just my opinion. Okay, any other questions or comments on the warm-up? Okay, let's go over the homework. I know there were some troubles and questions with 7. We'll take care of that today before we finish our notes. Okay, number 1, Steve, can you tell us how many possibilities there are from your tree diagram? Good. Number 1 should be 9. And again, if you need me to draw your tree diagram or show you how to get this with the multiplication counting principle, let me know, and I'll do that. Alexis, number 2. Good job. Jackie, number 3. Close. A little more, though. Camille? 12. Grace, number 4. Why did I skip 4? Number 4. Good. 12. Number 5. Peyton? Good job. Number 6, Nathan S. Good. 24. Okay, since 7A is already up here, the answer is 10,000 extensions. I will go over that in a couple minutes if you need me to. Geo, 7B. Nope, but that's okay. I wanted you guys and girls to try. Abigail? Good job. That quick explanation helped, huh? Good. Neil, 7C? Good job. Hey, I'm impressed. Raise your hand if you got at least 2 of these right on number 7. Just curious. Okay, raise your hand if you got 1 of them right for number 7. Okay, that's all right. All right, so let's start with 7, and then I'll go back to other questions, okay? Okay, Geo, what? No, we didn't round. There's nothing to round. Okay, let me go through them, okay? 7A said, well, actually, the question is, so a telephone extension in a company uses 4 digits. So, for example, when parents call me, or if I have to call someone, my extension to this room is 4019. So most workplaces, you'll have an extension that's 4 digits. So they're telling us here, or they're asking us in Part A, how many extensions are possible if there are no restrictions? Yesterday I told you to write down under no restrictions, that means there can be repeats. Okay, there's not any restriction, so my extension to this phone could be 4444. It's not, it's 4019, but you could have repeats. Since you can't have repeats, you can take the first option for your extension has 10 digits, right? The first number you pick, there's 10 digits possible. The second digit that is chosen for your extension, there are still 10 digits possible. Same thing for the third and fourth. You're allowed to have repeats, so there are 10 digits possible every time we try to pick a number for your extension. Nathan S. It is 0 through 9. There's 10 digits. But, so 1 through 9 is 9, plus 0 is 10. Can we say that again? So not, and I think I know what you're thinking, Nathan S. It's not that there's 10, not that it goes 1 through 10, it goes 0 through 9, like you just said. But if you count those digits, there's 10 single digits that we can use. But that's not what we're doing. We're not multiplying what the highest number can be. We're multiplying, Nathan asked, how many options of numbers we have. So we have 10 options. We could use 0, we could use 1, and I could count all the way up to 9. Is that clear or no? You can say no. Is anyone else confused on that part of it? Okay. Before we go to B, does anyone else have questions for me, Ray? Oh, well, hold on then. Anyone else on 7A? Is it anything to do with 7A, Ray? Okay, then hold on. Okay, let's go to B. So B says, how many extensions are possible if the first digit cannot be a 0 or a 9? So now for 7B, the first digit cannot be a 0 or a 9. If you can't have those two numbers, how many options are possible for this first space, Alexis? Good. There's only 8 digits possible since the first number cannot be a 0 or a 9. It doesn't say anything else about these digits. So how many numbers are possible for the second part? Amberly. Good. Camille, the third part. Good. Greta, the fourth part. Awesome. So 8 times 10 times 10 is 8,000. That's it. Okay, let's go to C. C says, how many extensions are possible if the first digit can only be a 1? So I'm going to draw 4 lines here. Gio, if the first digit can only be a 1, how many options are there? Good, 1. Kevin, there's not any restrictions on the second digit, so how many options? Good. Peyton, for the third, how many options? Good. Neil, for the fourth, how many options? Good job. So 1 times 10 times 10 is 1,000. Give me a thumbs up, thumbs down, thumbs down on those 3. We're going to do more today, but I just want to see if that helped a little bit. Or maybe a lot. You guys all have thumbs up. Is that much easier now? Okay. All right. Any other questions on the homework? Ray, we'll start with you. I do. Question 8, part A is 17,576,000. Okay. Part B is 11,232,000. Got it? I did not. He did it by accident. I didn't assign 8. Amberly. Okay, number 3, you got 10. Okay, so I guess I should ask you what your tree diagram looks like. Did you make a tree diagram? Okay. Okay, hold on. Let me show it. Okay, let me show it to her. Okay, what is at the top of your tree diagram, Amberly? Did you have a button down? Yeah. Okay, so you should have a t-shirt, button down, or sweater first. And then underneath that, think about it, you need to have pants with your outfit, I hope, right? So then underneath, I guess the wording's kind of weird. You should have jeans or khakis underneath that. And then either a red coat or a blue coat. So think of like your full outfit. You should have a shirt, pants, and then a coat if it's cold out. You don't want to either pick from a shirt or pants. That would not be good if you came to school like that. So I know the wording is weird on that. Try to use your common sense. Not that you guys don't have it, but try to think of, okay, we need to make sure this person has on the correct items. My questions on the quiz on Monday are worded much better. Sometimes the homework packet will run things together. Drew? Yeah, I was just getting to that. So red, blue, red, blue, red, blue. You know what I mean? Okay. 2, 4, 6, 8, 10, 12. So do we need to go back to practice counting? I'm just kidding. Okay, you don't count everything. So here's what you do, Ray, on a tree diagram. In regards to how many possible outcomes there are, you need to count how many are at the very bottom of the tree. That takes care of everything because, look, red coat goes with jeans, goes with t-shirt. So you might wear t-shirt, jeans, and a red coat. That's one option. Your second option is t-shirt, khakis, blue coat. That's two options. And you can keep counting. The bottom of the tree counts for all the possible outcomes. Now, you could also use the multiplication counting principle on this one. You could have taken 3 times 2 times 2, which gives you 12. David, don't forget your book. I think that's your book. It's not? Okay. Drew, you had your hand up. You did what? Okay, are you okay now? Okay. Anyone else? Questions on anything on the homework? Positive. Okay, I want you to flip over to number 8 real quick. I want to do this one with you, and then we're going to go back to the notes. So Ray, kind of just hang out with us for a little bit. Okay, so 8A, I want you, yes, Peyton. Just borrow a different one for Ting, if you don't mind. Put that on Miss Wingrove's desk, and we'll put batteries in it later. Okay, so 8A asks us, or says here, you are choosing a computer password. The password has 3 letters followed by 3 digits. Part A says, how many passwords are possible if the letters must be uppercase? Okay, so we need to have 3 letters, 3 digits. I want everyone to make 6 empty lines underneath letter A. What are you doing? You solving these? Okay. Okay, so if the 3 letters must be uppercase, how many options do we have for this letter, Nathan S.? Good, 26. How many options do we have for the second letter? Grace? Good, 26. It doesn't say anything about not repeating. So guess what? We're going to assume you're allowed to repeat. Shane, how many letters are we allowed to have for the third option? Good job. Okay, so now the next thing says we must have 3 digits. Nathan M., how many digits do we have to choose from for this spot? Good, 10 times 10 times 10. So this one's pretty easy. All we're doing is multiplying 26 times 26 times 10 times 10 times 10. I think I said 3 26s. If not, 3 26s and 3 10s. Steve, okay, what did you get? Good job. So about 17.5 million passwords are possible. That's a lot of passwords. Ben. Okay, hold on. You're ahead of me. Any questions on A? Okay, let's go to letter B, and then we're going to go back to the notes. So draw 6 empty lines for letter B still. Letter B asks us how many passwords are possible if no letter or digit can be repeated and the letters have to be lowercase. So no repeats, the letters have to be lowercase. Ben, how many options are possible for this spot? No, I don't want the answer. How many? Okay, that's what I want. Nathan S., how many are possible for this spot? Good. Jackie, how many letters are possible for this spot? Good job. Joseph, how many digits are possible for this spot? Good. Michelle, how many for this spot? Good. David, how many for this spot? Good job. After you multiply all of them from left to right, Ben, now tell us what you got. Good job. Passwords are possible. Ray. Okay, because you can't repeat. So let's say for your password, Ray, let's say you chose letter A here, okay? You cannot have repeats. That means that we cannot use letter A here, and we cannot use letter A here. If you can't use letter A, but you can use anything else, we have 25 other letters of the alphabet to choose from. And then let's say for here you use B, just pretend. For this spot, you cannot use A or B. That leaves 24 more letters to use. Make sense? Okay. Anyone else? Questions on that? Comments on that? Okay, let's look at one more, number 9, because I was actually going to have you do number 9 in your notes, but let's do it here. Okay, number 9. Dylan, Miss Wingrove can find your pass if you need her to. Did you do okay? Okay. All right, number 9 says you spin the spinner 2 times. We need to find the probability that the spinner stops on a 3, then on a 1. This one's tricky. So we need to find the probability that the spinner stops on a 3, then on a 1. Anyone have any idea how we would go about setting this up? Shane? What are the fractions? Grace, were you going to say the same thing? Okay, that's okay. Kevin, were you going to say the same thing? You had your hand up. I thought you did. Okay, never mind. Okay, so I am not going to get into a lot of detail with this. This is an example of a compound event. When we get to Algebra 1 next year, we're going to talk a lot about these. This one in particular is an independent event, which is why you multiply them. If you ever see a problem like this, the way that your book does it is they always have you multiply. So anytime you have 2 different probabilities and they want you to find the probability of both, just multiply them together. So your answer here is 1 over 36. Nathan S? Okay, sorry. Okay, any questions on that? I wanted you to do that for homework, but I didn't teach you enough to have you do that. All right, let's flip over to your notes. I want you guys and girls to go to page, go to page 22. Let's start there. Okay, and there was something else on example 4 that I wanted to ask you about. So let's start in your notes on page 22. Underneath where we wrote some work down on page 22, example 4, I want to give you one more part to that, okay? So I'm going to ask you now, what is the probability that you're going to get the correct combination if you cannot have repeats? So I want you to write down somewhere underneath example 4, correct combination, and I'm going to put here no repeats. So very similar to what we discussed yesterday, but now I'm going to take away the option of repeating. Plus, this is a good problem to talk through again. Okay, so again, let's say you're trying to get into your locker or someone's locker. How many favorable outcomes are possible? In other words, how many correct combinations are there to someone's locker combination? Alexis, good. There's only one way to open up someone's locker. There's one correct password. There's one correct code, just like getting into someone's email or getting into someone's, I don't know, phone, voicemail, anything. So there's one option. If you cannot repeat, Nathan S., how do we figure out how many options we have? Awesome. All we're doing now, since there cannot be repeats, is we're taking 40 for the first spot times, if we already chose a number, the second number in our password, there's only 39 options. So times 39 and then times 38. Go ahead and multiply all those, and we'll have someone tell us what you got. Josh, what did you get? Good job. 59,280. So there's a 1 over 59,280 chance of getting into this locker. Questions? Neil? Okay. Questions on that? Okay, I want... Okay, I want you guys and girls to try this one. On the side of your notes or at the top, and then I need to move on to the next part. So I want you to write down, without me going through this, what is the probability of creating a password with no repeats, 2 letters and 2 numbers? I'm also going to say that the letters are not case sensitive, which means that an uppercase and a lowercase are the same thing. So if my password is Galliotto, all in capital letters, it doesn't matter if I type it in as lowercase or capital. It recognizes it the same way. Does that make sense? Correct. So it's not case sensitive, which means you don't have to have it exact. An uppercase and a lowercase, the computer thinks are the same thing in this example. So find the probability of creating a password with no repeats, 2 letters, and 2 numbers. And when you get an answer, put your hand up. You can write it at the top of your notes or on the side. Awesome. Good job. Is that your answer? Okay. Good job. Good job. Very good. Careful, no repeats. Good job. Awesome. Good job. Very good. Good job. What? Yeah, I said good job. Yeah. Wait. Don't keep 1 over, though. Good job. Do you have your answer? Are you thinking about it? What? Okay, where's your calculator? Probably because you haven't been taking notes. Did you take any notes yesterday? What happened to these? Okay, where's your calculator? Get that out and try to set it up. Tiger, good job. It's like a present. Good job, good job. Where's your answer, David? We'll try that again. Good job. Greta, just not 1 over though, because we're not trying to figure out the probability of us getting it correct. We just want to know what is the probability, or how many chances do we have of getting a password? How many options are there? I probably should have worded that a little bit differently. Good job. Good job. All right, Gio, let me ask you this. What do you need to multiply together? Good. And I probably should have worded this as how many different possibilities are there instead of what is the probability. So my fault for wording that a little bit incorrectly. So how many different possible passwords are there with these restrictions, Drew? Good job. Any questions on how to set that up, Grace? Okay, so if it was case sensitive, it would be 52. So if the computer thought that an uppercase and a lowercase were different, then it would be 52. But I said it's not case sensitive, which means the computer does not know the difference between an uppercase and a lowercase. Does that make sense? And I always use the word case sensitive in your review and on your test. I think your book might use it once or twice, and I will make sure we clarify that before your test Monday. Anyone else? Okay, let's go on to more factorial stuff. Okay, and my calculator is actually working today, so I'm going to pull that up and put this next to our notes. I need you to have your calculator up next to your notes as well, just like I did. Okay, so we talked about factorial as being the number of ways to arrange objects. And the definition is it's the product of integers from 1 to n being the number of objects. So we now need to figure out how many ways there are to arrange letters in a word. Now, if you think about this for a long time or a little bit, I kind of think this is a weird example of using factorials. For some reason, a lot of math books start off with these examples. So here's what I want you to think about. I know you all know how to spell. Let's pretend like we have those magnetic letters. Remember those when you were little and you could put them on the fridge? You know what I'm talking about? So pretend like, you know, you're babysitting or you have a younger sibling and you give them these magnetic letters. And you say, all right, they're 2 years old. I want you to try to spell equal on the fridge. Here are all the letters in the word equal. Now, the chances of that happening are not very good, right? I know my niece is 17 months old. She'd never be able to do that. We need to figure out how many ways there are to arrange all the letters in the word equal. I know there's not much application to this, but this is good practice for arranging objects. I think the book uses this just because they're easy examples to type out and they're easy examples to explain. Ben? Okay, you're way ahead of me. Okay, so equal. Did you say 20? Okay, good. So equal, let me ask you this first. Does equal have any repeats in it? No, there's no repeats. So you want to ask yourself, how many letters are in the word equal? There's 5 letters in the word equal. How many ways are there to arrange all the letters in the word equal? It's 5 factorial, like Ben said. So we're going to take our calculator. We're going to type in 5. We're going to go to math, PRB. Now I can do it with you. Down to number 4, which is the factorial. Hit enter. As Ben said, we get 120. So there are 120 ways to arrange. You could either say 5 different objects that do not have any repeats, or arrange the letters in the word equal. While you think about that for a second, any questions on that? Kevin? Do you? Good, I'm glad to hear that. All right, let's go to the word that. What is, besides it being a different word, what is different with the word that than the word equal? Oh, lots of hands. Grace? Awesome. It has a repeat. So anyone know what to do before I tell you? Abigail? Nope. That's okay, though. Good thought. Ray? That's what Abigail said. I think it's hard to hear with the vent back there. Gio? And then you need something else. Yep. Not minus. Josh? Why? Good job. That's all you do. You take how many letters there are with a factorial next to it, and then divide by repeats. In other words, there's 2 T's, so since there's 2 T's, the T's repeat, you divide by how many of that letter there are that repeat it. So 4 factorial divided by 2 factorial, you can either do this mentally and say to yourself, 4 times 3 times 2 times 1, divided by 2 times 1. Both 2 times 1's cancel, so you really just have 4 times 3. Or use your calculator and type in 4 factorial divided by 2 factorial. Amberly, what'd you get? Good job. Peyton? Because of the number of repeats. You're always, it's kind of like our little factorial formula. You always have to divide by the repeats because technically this is considered as 1 letter, but there's still 2 of them. You know what I mean? Alexis? Yep. And I'm going to show you the different options. Yep. Abigail? You really don't, because 2 factorial is the same thing as 2. Hold on, that's a whole different question. So let me get to it. Nathan S. You could. Yeah, definitely. There's a couple other ways that you could solve some of these, but yeah. I think Nathan S. with the harder ones, with the longer words, I think it's easier to do it with the division. You'll see what I mean once we get to Pennsylvania, but that does work. Okay, let's go to level because Abigail brought up a good point that I need to mention. So level has 5 letters. So we have 5 factorial. Divided by, we now have 2 sets of repeats. So there's 2 E's and there's 2 L's. You represent that as 2 factorial times 2 factorial. So let me ask you this. Is 2 factorial times 2 factorial the same thing as 4 factorial? No. So that's what Abigail was asking. I'm pretty sure, right? 4 factorial is 24, but 2 factorial times 2 factorial is 4. Very different. So the point of that is, do not multiply these together by using factorials. So don't change this to 4 factorial. You cannot do that. My second point is, when you put this in your calculator, you must have parentheses around the denominator. The 9th graders learned this about 2 months ago, and some of them forgot that. No matter how many times I said this, you need to make sure you have parentheses here. Remember, your calculator is not as smart as you. If you don't tell it what to do in regards to order of operations, it's not going to work. So let's go over to our calculator. We're going to type in 5 math prob number 4 divided by, open up your parenthesis, 2 math prob number 4 times, because you're really multiplying the denominators together. Sorry, Steve, can you not see? 2 math prob number 4 and end parenthesis. All of your calculators should look just like mine. Is anyone having trouble typing that in or finding anything? Ben? Divided by, not 24. What's 2 factorial times 2 factorial? No. Did you just listen to what I just said? 2 factorial times 2 factorial is not 4 factorial. So here's why. 4 factorial is 24. 2 factorial is 2. So 2 times 2 is 4. They are not equal. So you could do 120 divided by 4. Okay? Anyone else? Questions? Okay, hit enter. You should all get 30. There are 30 ways to arrange all the letters in the word level. That takes into consideration the 2 letters that are repeated. Nathan S.? No, that's not right. You did 5 factorial divided by 4 factorial or 5 factorial divided by 4? Okay, that's why. Because 2 factorial times 2 factorial is 4. Do you know what I mean? I think you need help on the graphs, the parabolas. If Nathan S., does that make sense? Okay, Peyton. No, it's not 9 factorial. Do not multiply them. 3 factorial times 3 factorial is really 36, because 3 factorial is 3 times 2 times 1, which is 6. You know what I mean? So my point to that is do not multiply them together. Leave them. Yeah, that's what I said. Yep. Yeah, 2, not 4 factorial, though. Nathan S. Okay. Yeah, 2 factorial times 2 factorial is 4, not 4 factorial. I tried to make that point. Is everyone else okay with that? And you can ask if not. Nathan M. I know. You're going to need to either borrow one of my scientific ones or get one at some point. You don't have a factorial button anywhere on yours? Okay, I'll help you in a couple. Let me get through the rest of these, then I'll help you. Okay. Okay, let's go to the word Pennsylvania. So skip multiply. Let's go to the word Pennsylvania. Okay, can someone tell us how many letters are in the word Pennsylvania? Grace? Good. 12 letters in the word Pennsylvania. Who can tell us what repeats? Ben? So there's 3 N's and there's 2 A's. So we have 12 factorial divided by 3 factorial times 2 factorial. You okay, Steve? Sure? You have a headache? Okay, okay. Making sure. Now, that's how you set it up. There's 2 repeats. There's 3 N's, 2 A's. Please keep parentheses around your 3 factorial and 2 factorial. Go ahead and put that in your calculator, and then put your pencil down once you get it. So 12 factorial divided by, all in parentheses, 3 factorial times 2 factorial. Oh, is that what you got? Is that for something different? That's not right. Did you have parentheses? Try that again. Did you put parentheses around like I did? That's still not right. That's still not right. What is this for? Oh, the closing. I'm sorry. Try this again now. Oh, good. 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 Good job. Good job. Very good. Good job. Good job. Where's yours? Good. 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 All right. David, what'd you get? Good job. Amberly. I was going to call you Abigail. Sorry. Okay, here's why. The calculator doesn't realize order of operations. So if you don't put parentheses, it will do 12 factorial divided by this times this. The calculator has to know that it has to do what is inside grouping symbols first and then divide. Now, I know we know that. If we didn't have parentheses here, we know to do that, but the calculator does not understand that. Okay? Ben? No. 3 factorial is 6. 3 times 2 times 1 is 6. Times 2 is 12. You're doing that still. 3 factorial times 2 factorial is not 6 factorial. And it's also not 6. Think about what the factorial means, then multiply if you want to do it that way. Okay? Anyone else? Okay. Give me a thumbs up, thumbs down, thumbs down before I decide where I want to go next here. Shane, thumbs up, thumbs down, thumbs down. Okay. All right. I need you then. Let's open up our homework packet to page 91. Because I was going to have you figure that out, but I'm going to have you do that for your homework. Okay, so page 91, I believe it should look like mine, but obviously not. The answers are not on yours. So page 91, there is a back and a front. Now don't start yet. The first thing I need you to do is flip it over to the back. I need you to add a couple problems. So you're doing page 91, front and back, but I need you to add number 7 to be baseball. Just add them and I'll explain why. Next to number 7, so list them next to each other. Number 8 is the word probability. If I can spell. Okay, ready? One more time. On the back of 91, at the bottom, underneath number 6. Gio, do you have your homework even out? Okay. On the bottom, I want you to add these numbers. So after number 6, you're going to add, Kevin, you should be on the back page. The back of 91. What? I'm not done yet because I was explaining to you guys where it is. So on the back of 91, underneath number 6, which has the pizza problem, I want you to add these. Is everyone with me now? Kevin, you with me now? Okay. Okay, baseball, probability. Number 9 is flower. And number 10 is Mississippi. Okay, so after you add those at the bottom, hopefully you have a little bit of room, you're going to figure out for that little part how many ways there are to arrange the letters in those words. If you need more room, use your notebook or use loose leaf and just leave it behind your homework assignment so I can see it tomorrow. Okay? So is everyone clear on where you added those and how to solve those? It's just more practice before we start our review tomorrow. Okay, flip back to the front. Okay, let me just go over a couple things with you. Yeah, you're doing front and back of 91. You're doing front and back. Okay, so I need to do number 1 with you. So let me do it up here. Okay, number 1, there is an A and there is a B. So we're going to start with A and then we'll go to B. Okay? So number 1 asks us, or we have to do for all of these, we need to find for part A how many ways there are to arrange all the letters in the word tack. So can anyone tell us for 1A, how many ways are there to arrange all the letters in the word tack? Alexis. Good. 4 factorial or 24. There's 4 letters in the word tack, so you're taking 4 times 3 times 2 times 1. Neil? Question? Okay. Part B says, how many ways are there to arrange 2 of the letters in the word tack? This one's tricky. How many ways are there to arrange 2 of the letters? Josh? Nope. Nathan S? What'd you say? No? Ray? No? Neil? No? Gio? How'd you get that? Go ahead. Oh, I got you. Yeah, that's not the right way. But I see what you're. That was a coincidence. Peyton? Okay, that won't always work, but it works this time. So here's what you do. So to figure out how many ways there are to arrange two of the letters in the word tack, ready? How many ways are there to put the first letter down? How many spaces are there? Alexis? 4. Okay, so there are first letters down. It doesn't matter where you put it. There are still 4 empty spots. Grace, how many spots are there to put the second letter? Good. There you go. 2 letters are down. 4 times 3 is 12. Did the light bulb go off?
Yeah.
Did it? Okay. I figured I should do that with you. Okay, so much easier than you thought, right? 2 and 3 are the same process, okay? 7 through 12, you probably need to borrow my calculator. If you borrow mine, please make sure you have your number and you're not losing it, okay? 13 through 15 are just word problems using factorial. And then flip over to the back real quick. Numbers 2 through 6 are using the multiplication counting principle. So I'll say that one more time. 2 through 6 on the back. Is everyone listening? Kevin, 2 through 6 on the back are using multiplication counting principle. I took this from an Algebra 1 worksheet and kind of mushed it together with one of yours so that you had a good practice for this. Okay, so back and front, please make sure you also do the problems that I added. Questions for me, Peyton? What number did you take? 23. Okay, just make sure you bring that one back tomorrow. I'll remember. We'll fix yours. I know. Greta. Yes. Yeah, because it's a 3-letter word. Now, number 3, that won't happen. Grace. Use 26 letters. So this computer, good question. For number 1 on the back, the computer does not know the difference between uppercase and lowercase, so use that it has a total of 26 letters. And on my review, that's clarified much more than this is. David? Well, I changed my mind, sorry. I was going to do some some problems in the book with you. Camille, hold on a second. I was going to do some of that before we did homework today, but I changed my mind. So sorry. All right, that's it. If you need your calculator, just make sure you bring it back tomorrow. Boys are first today.